Okay, 9.2 is about different ways to calculate how many different ways you can do things. So if, for example, if you think about rolling a six-sided die and flipping a fair coin, how many possible outcomes do you have? Well, when two or more events are independent, the total possible outcomes are the product of the number of outcomes for the individual events. You have six outcomes for rolling the dice, 2 outcomes for flipping a coin. So 6 times 2, 12 outcomes in the combination of the 2 events. So let's see how this applies to more problems. Angela has 9 blouses, 8 skirts, and 13 pairs of shoes. How many potential outfits can she create? Well, you just multiply all the possibilities together, and that's it. So you have 9 times 8 times 13, which is 936 outfits. How many 5-character license plates can be made if the first 3 characters are letters and the last 2 are digits? The first letter must be P, W, E, Q, L, or K. So the first letter, we have 6 options, but everything else, so 26 letters in the alphabet for the second and third. And then the last 2 are digits. There are 10 digits, 0 through 9, and you just multiply those all together to get, there are 405,600 different license plates, given those parameters. A menu has 6 different breads, 3 different salad mixes, 5 different dressings, and 8 different soups. How many ways can you order soup, salad, and breadsticks lunch? Again, you multiply. And since you're going to have a calculator in this test, it'll be pretty easy. 720 different lunches on the soups, salad, and breadsticks menu. Easy enough. Now, not every probability is going to be that simple. There are 2 types of situations, permutations and combinations, entirely dependent on whether order matters or not. A permutation is the number of different orders you can arrange R items when selecting from a group of N items. What that means is you have like 10 people and you're taking 4 of them and putting them in order. And where first, second, third, and fourth mean different things, that's a permutation. Now, if you see this NPR, which is a button in your calculator, is n factorial divided by n minus r factorial. So what does factorial mean? For example, 5 factorial means 5 times 4 times 3 times 2 times 1. The number times itself, or times all the other whole numbers down to 1. So let's just practice a second. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you put that in the calculator or you did it by hand, you would get 5,040. Factorials get out of hand really quickly. Now, if we look at 11 factorial divided by 9 factorial, that's 11 times 10 times 9 times 8 times 7 times 6, all the way down to 1, over 9 times 8 times blah, 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 blah. Now, what do you see when you look at these? All of these numbers from 9 on over will cancel, and it's really just 11 times 10, which is 110. So factorials have a really nice way of canceling, that if you have a larger factorial divided by a smaller one, it's all of the numbers up until the smaller one that stay. Now this is primarily for you to practice in the calculator. 10p4, which is 10 permute 4, means you have 4 items and you're choosing 10 of them. It's really 10 factorial over 10 minus 4 factorial if you're doing it by hand. So 10 factorial over 6 factorial, just 10, 9, 8, and 7. And then everything down from there cancels. But if you do that, you get also still 5,040. 20 permute 8 elements is 20 factorial over 20 minus 8 factorial, which is 20 factorial over 12 factorial. But still, it's 20 down to 13, which is still going to be a really large number. So in your calculator, if you find the probability section, there's an NPR button. If If you type in 20NPR8, that's the same as the 20P8 there. This is how you'll put it in the calculator. Anyway, this is a massive number, 5079110400. So that's only, what, 5 billion? So if you have 20 items and you're arranging 8 of them in an order, there are over 5 billion ways to do it. 79 factorial over 77 factorial. Unlike this one, which you can put in the calculator, these, you cannot put 79 factorial into the calculator. It will overflow. So it's important that you know how these work if you get something like this. Of course, remember, this is 79 all the way down. This one is 77 all the way down. And everything from here on over is going to cancel. So this is really just 79 times 78. Which you actually can do. Even though those two numbers are too big for your calculator, if you simplify, it can be done. Now, besides permutations, there's combinations where order doesn't matter. And this divides by an extra term because it's the number of ways that I can pick the same group of people. So if I'm picking a group of 3 numbers just to give like 3 people Starbucks gift cards that are $25. Do you care if you're first picked or third picked? No, you just care that you're picked. So I could pick 1, 2, 3 or 3, 2, 1 and the same group of people is picked. This is mostly just practice for you to put into the calculator though. We'll do 1. One thing about combinations is the 2 numbers in the denominator always add up to the number in the numerator. So that's a good way to remember it. 10 and 4, and then 4 plus 6 is 10, so this is an easy way to do it. This is 10 times 9 times 8 times 7, and everything else cancels with a 6. We still have 4 times 3 times 2 times 1. Now we know 4 times 2 is 8, so these cancel, and 9 divided by 3 is 3, so this is 210. But I'll let you get used to putting this in your calculator and skip down to how we see the difference between these two things. So in a word problem, your first goal to determine if it's permutation or combination is if order matters. So there are 12 horses in a show. The top 3 winning horses receive money. How many possible winning orders are there? Well, if the prices are different, then I would say order matters. Usually first place wins more. If it's order matters, it's a permutation, which means you'll do 12 and PR3 in the calculator. And if you do that, that's 1320. One thing about permutation questions, they can also be done by the counting method. There's 12 different horses who can get first, 11 who can get second, and 10 who can get third. So if you do that same method at the beginning, the fundamental counting principle, it also works. Now, if it's a 12-horse competition and 3 horses qualify to advance to the next level, how many different 3-horse sets can advance? It doesn't matter if you're first, second, or third, you all advance. So this means order doesn't matter. That's 12 and CR3, which is much smaller. It's only 220 different groups could advance. So sometimes the wording here is a little bit subtle on which one you're going to do. In how many ways can a 4-person committee be selected from a group of 10 people? This one, order doesn't matter, it's just a committee. But in how many ways can you pick a president and a treasurer for your 16-person club? This one, order does matter. So this one would be 10N CR4. This one is 16N PR2. And then you'd put those in the calculator. On an 11-person baseball roster, how many different ways can a 9-person batting order be arranged? Well, if you know anything about baseball, which you may or may not, batting first and second or third or fourth is very different, so here order matters. So this is 11 NPR 9. Now, on an 11-person baseball roster, how many different ways can a coach select a group of 9 people to bat? Here, if it's just the group to bat, order doesn't matter because it's not putting them in order. So it's 11 NCR 9. And that's a huge difference between those two in terms of number. And that's really all there is in 9.2. 9.3 is the word problems that go with this.